must have somehow been in a disk, and parts of that disk coalesced into planets. But that's extremely surprising. I don't know that anyone really understands that process yet.
Although the pulsar planets are believed to have rocky surfaces, it's unlikely they would be a platform for life, and any visit by humans would be short-lived. As the pulsar rotates, it emits well-focused beams of charged particles from its poles, creating a rotating spotlight of horrific radiation.
Standing on a pulsar planet would be a very dangerous proposition. There would be high-energy radiation all around you, just an onslaught of particles and waves. And the radiation field would be so strong that it would probably destroy your living tissue, and it would certainly cause cancer and mutations very quickly. But it would probably kill you. If you were really unlucky, or lucky, I suppose, if you're going to die anyway, might as well die in a spectacular way, you would be in the beam of the pulsar. So every rotation, the beam would flash past you, and you would see this incredibly bright beacon, like a lighthouse really close to you, just flashing in your face. It would not be a very hospitable environment, no way.
While the pulsar planets might not be nice places to visit, they have taught us something fundamental about planet formation in the universe.
These planets, weird planets around a neutron star, have taught us that planetary formation appears to be relatively easy. Gravity appears to like to pull stuff together when there's enough stuff in a given region.
If nature is so good at making planets, even under difficult circumstances, then the odds are fairly high that the universe is full of planets, and that somewhere out there in the cosmos, other Earths are waiting to be discovered. But if that's the case, then where are the Earths? Why haven't we found them yet?
The first planets that were found in the late 1990s were massive planets, 300 times the mass of our Earth. And it's really not a surprise that we found the most massive ones first. Like the giant redwood trees behind me, they were the easiest to see from the enormous distances that we were looking. So when we find stars where we say, there's just one single massive planet, one giant redwood, that's almost certain to not be true. There's almost certainly a forest of planets and asteroids and comets also orbiting that star.
As astronomers continue to scrutinize alien solar systems, they are edging ever closer to finding Earth-like planets. This is Gliese 436b. It's a world roughly 20 times the mass of Earth, similar in mass and size to Neptune. It orbits a star 30 light-years away in the constellation Leo.
I'm so excited about Gliese 436, I'm almost jumping out of my clothes. It's the most important discovery since 51 Pegasi, maybe even more important.
What has Jeff Marcy so excited is that this planet was found to have a density of 2.1 grams per cubic centimeter.
What does that mean? It's a spectacular number, because every school child knows that the density of water is 1 gram per cubic centimeter. And we also know that rocks that you pick up on the street, the density of our Earth, for example, as a rock, is about 5 grams per cubic centimeter. And therefore, this planet, around 436, is composed of a mixture of rock and water.
A planet made of rock and water sounds tantalizingly Earth-like, but Gliese 436b has so much water, there would be no land masses exposed at all. And you wouldn't want to take a swim in the oceans of this watery alien world. There may be a layer of liquid water on the surface, but below that, things begin to get a little weird.
There's so much water that the sheer gravitational force of the water molecules pressing down toward the center will crush the water so tightly that the water molecules are almost touching each other. It's a very odd type of water. In fact, we call it ice even though it's not cold, because the water molecules will be arranged in a structure like ice, but only due to its high pressure.
Clearly, Gliese 436b isn't quite an Earth-like planet. But what about this alien world? What would make an alien planet truly Earth-like? It should be made primarily of rock, with enough water for oceans, but not so much water that the land masses are completely submerged. It would also have to be in its star's habitable zone.
The typical idea for a habitable zone is the range of distances from a star where an Earth-like planet could have liquid water at its surface. The idea would be that if you took Earth and pushed it in too far, the oceans would all boil away, and that's bad for life. Or if you took the Earth and pushed it out too far, the oceans would all freeze, and that's bad for life.
In our own solar system, the habitable zone ranges from Mars's orbit into as close as where Venus orbits. But the habitable zone in alien solar systems varies, depending on how hot the star is. Currently, our best hope for finding habitable Earth-like planets is to look around cool, dim stars called red dwarfs or M dwarfs.
The M dwarfs themselves are very special stars. So our sun might be a 100-watt light bulb. An M dwarf is perhaps a 10-watt light bulb. And so what that means is that to stay warm enough so that you have liquid water, not ice, but still not too hot, you move the planet in much closer. And those close planets are easier for us to detect with our technique because they tug on the star more.
One of these M dwarfs, called Gliese 876, has been found to have at least 3 planets orbiting it. 2 of them are gas giants, but the third, Gliese 876d, is one of the smallest planets discovered so far, at roughly 6 or 7 times the mass of the Earth. It's also just on the edge of its star's habitable zone.
The planet orbits in just 1.9 days around its host star, but because the host star is so low in luminosity, it puts it on the edge of what you might imagine the habitable zone to be. There could be some region, a ring around the planet towards the back side, where the temperature is actually just right for liquid water to exist.
When it was first discovered, scientists hailed this planet as the first of the super Earths.
7 times the mass of the Earth sounds so close to the size of our Earth that you wonder whether or not it's a rocky planet, maybe with a thick atmosphere.
But today, the experts are unsure whether this is a large rocky planet at all. Like Gliese 436b, it may be completely covered in an ocean of super dense water.
Well, to call it a super Earth is to suggest that we've found a planet that's a close cousin of our Earth. I would now rather think of it as a distant cousin, not unrelated to our Earth, but far enough away, indeed more like Neptune in our own solar system, that has a big rocky core, but surrounded by a big envelope of water.
So the race continues to discover the first truly Earth-like planet. At the University of Arizona, astronomer Laird Close is hoping to capture the first picture of an alien Earth. But to do that will take a giant leap in telescope technology. Here at the Steward Observatory Mirror Lab, in a cavernous space underneath the bleachers of the university's football stadium, engineers are working on the next generation of super telescopes.
This is the largest mirror that's ever been made. This mirror is 8.4 meters across, but it's just 1/7 of the size that's needed for the giant Magellan Telescope. And together, when combined with 7 other mirrors like it for the giant Magellan Telescope, we will be able to actually directly image extrasolar planets and maybe even Earth-like planets around alien suns.
Scheduled for completion in 2016, this telescope will be able to make images up to 10 times sharper than the Hubble Space Telescope. NASA and the European Space Agency are also developing several missions that will use space-based telescopes to search the stars for our planetary kin.
This will be incredibly exciting for humankind to know whether or not around those little points of light that we see in the night sky, whether there's Earth-like planets tied in orbit around those stars. As technology improves, we're going to be able to find planets that look much more like the Earth, planets that perhaps have life on them, and maybe even planets that have forests and steam trains.
The astronomers who have dedicated their lives to this quest all believe it's only a matter of time before we find the first truly Earth-like planet.
The most exciting thing I can tell you is that we are now routinely discovering, commonly discovering planets that are a mere 5 or 10 times the mass of our Earth. We're not quite to the point where we're finding Earths, and that's where we really want to be. But we're finding planets that are ever so close to our home planet.
So when we actually do cross that final threshold and do find evidence that there's a habitable planet out there, this is going to be quite an epical event for humanity.
People should not worry too much yet that we haven't found any Earth-like planets because, well, a lot of effort's going into it right now, and I think it will be done in the next 10 years. Yeah, stay tuned.
Are we just insignificant specks? Is the universe welcoming or hostile? We could stand here forever, wondering. Or we could turn our back on this beach, leave home, to see the universe, from here to its edge, to discover its wonders, confront its horrors. Beautiful new worlds, malevolent dark forces, the beginning of time, the end of the world. Would we have the courage to see it through? Or would we run for home? There's only one way to find out. The edge of space, only 100 kilometers up, just an hour's drive from home. Down there, life continues. The traffic keeps moving, stocks go on trading, and Star Trek is still showing.
Looks favorable enough at this point that the race should go. The Blue Jays will be without starter Jim Clancy for a couple of weeks. This morning,
Order! Will the honourable gentleman resume his seat? Mr. Ashton.
But we have to leave all this behind. To dip our toe into the vast, dark ocean beyond. Into the shallows. Not too far from home. Onto the moon. Dozens of astronauts have come this way before us. 12 of them have walked on the moon itself. Just over 400,000 kilometers from home, 3 days in a spacecraft. So close, it's as if we've barely left home. Familiar, safe, within sight of Earth. It looks like a deserted battlefield, bombarded by millions of meteoroids and asteroids. But it's quieter now. It's obvious there have been no major collisions for millions of years. This brings back memories. The Apollo 11 lunar module. Neil Armstrong's first footprints. Looks like they were made yesterday. There's no air to change them. They should survive for millions of years. Maybe longer than us. Our time is limited. We need to take our own giant leap. Further than any human has ever traveled. Out of the darkness, a friendly face. The goddess of love. Venus. The morning star. The evening star. Sometimes she welcomes the new day in the east. Others, she says goodnight in the west. The planet's spectacular yellow clouds reflect the sunlight. That's why this is the solar system's brightest planet. A sister to our planet. She's about the same size and gravity as Earth. We should be safe here. But the Venus Express space probe is telling us these dazzling clouds are made of deadly sulfuric acid, that the planet's atmosphere is choked with carbon dioxide. It's ringing alarm bells. Venus is one angry goddess. The air is noxious, the pressure unbearable, and it's hot, approaching 500 degrees Celsius. Stay too long, and we'd be corroded, suffocated, crushed, and baked. Nothing can survive here. Like this. It's a Soviet Venera robotic probe. Its heavy armor's been wrecked by the extreme atmosphere. So lovely from Earth, up close, this goddess is hideous. She's the sister from hell, pockmarked by thousands of volcanoes. All that carbon dioxide in its atmosphere is trapping the sun's heat. This is global warming gone wild. Before it took hold, maybe Venus was calm, more like her sister planet Earth. If that's true, this could be our planet's future.
המסע המושלם, מסע אחורה לעבר וגם לעבר העתיד.
That we should turn back. But there's something hypnotic about the sun. Like Medusa, too terrible to look at, too powerful to resist, luring us onwards. On, like a moth to a flame. Dwarfed by, scorched by the sun, it's Mercury. Get too close to the sun, this is what happens. Temperatures swing wildly here. At night, it's minus 170 degrees. Come midday, it's 400 plus. Burnt, frozen, and look at those scars. A sign that Mercury had a violent past. The Messenger space probe. It's telling us something strange. For its size, this little planet has a powerful gravitational pull. It must be heavier than it looks. It's like a huge ball of iron, covered with a thin veneer of rock, the core of what was once a much larger planet. Maybe a stray planet slammed into Mercury, blasting away its outer layers in a deadly game of cosmic pinball. Whole planets on the loose, destroying anything in their path, even entire planets. And we're in the middle of it, vulnerable, exposed, small. Everything is telling us to turn back. But who could defy this? The sun, in all its mesmerizing splendor. Our light, our lives. Everything we do is controlled by the sun, depends on it. And more than that, it's the Greek god Helios driving his chariot across the sky. The Egyptian god Ra, reborn every day. The summer solstice sun rising at Stonehenge. For millions of years, this was as close as it got to staring into the face of God. 150 million kilometers from home, a 20-year journey by plane. Switch it off, and it's so far away, we wouldn't know about it for a whole 8 minutes. It's so big, you could fit 1 million Earths inside it. So heavy, its gravity controls the entire solar system. But who needs numbers? We've got the real thing. We see it every day, a familiar face in our sky. Up close, it's unrecognizable. A turbulent sea of incandescent gas. The thermometer rises to over 5,000 degrees. Down in the core, it's got to be tens of millions of degrees. Hot enough to trigger a nuclear reaction, turning millions of tons of matter into energy every second. More than all the energy ever made by mankind. Back home, we see this energy as light, feel it as heat. But up close, there's nothing comforting about the sun. It's so full of electrical and magnetic activity, it's bursting out in these huge incandescent gas loops called prominences. Each one releasing more energy than 10 million volcanoes. You could get the Earth through one of these loops and still have tens of thousands of kilometers to spare. And where they burst through, it's exposing the cooler layers below, making sunspots. They're a fraction cooler than their surroundings. It's why they look black, but they're still hotter than anything on Earth. And they're massive, too. Some of these are at least 50,000 kilometers across. A solar flare. A superheated stream of electrified gas blasting deadly radiation out into space. But one day, all this will stop. The sun's fuel will be spent. When it dies, that'll be it for the Earth as well. This God creates life and destroys it, demands we keep our distance. This comet has strayed too close. It's being boiled away by the sun's heat, creating a tail that stretches for millions of kilometers. It's freezing in here. There's no doubt where this comet's come from. The icy wastes of deep space. But look at all this steam, the geysers and dust. It's the sun again, melting the comet's frozen heart. A kind of vast, dirty snowball, covered in grimy tar. Tiny grains of what looks like organic material, preserved on ice since, well, who knows when. Maybe even the beginning of the solar system. Say a comet like this crashed into the young Earth billions of years ago. Maybe it delivered organic material and water, the raw ingredients of life. It may have even sown the seeds of life on Earth that evolved into you and me. But say it crashed into the Earth now. Think of the dinosaurs, wiped out by a comet or asteroid strike. It's only a question of time. Eventually, one day, unless we can find a way to protect ourselves, we'll go the way of the dinosaurs. The Earth is safe. For now. But if life on Earth was obliterated, we'd be stuck out here, homeless, adrift in a hostile universe. We'd need to find another home. Among the millions, billions of planets, there must be one that's not too hot, not too cold, with air, sunlight, water, where, like Goldilocks, we could comfortably live. The red planet. Unmistakably, Mars. For centuries, we've looked to Mars for company, for signs of life. Somewhere down there could be extraterrestrial life. But are we ready to find it? Ready to rewrite the history books, to tear up the science books, to turn our world upside down? What happens next could change everything. More than any other planet, Mars captures our imagination. Think of sci-fi films, comics. What follows? Martians. It's all just fiction, right? But what if there really is something here? If there is, it's living on a dead planet. The processes that make Earth habitable shut down hundreds of millions of years ago here. Red and dead. Mars is a giant fossil. Something's alive. A dust devil, a big one. Bigger than the biggest tornadoes back on Earth. There's wind here. And where there's wind, there's air. Air that could sustain extraterrestrial life. But it's too thin for us to breathe, full of choking carbon dioxide. There's nothing to protect Mars from the sun's ultraviolet rays. And it's cold, as low as -80 degrees, freezing water in the ground, at the poles, and even in the atmosphere, as snow. It's hard to believe anything could live here. But on Earth, there are creatures that survive in extreme cold, heat, and even in the deepest ocean trenches. It's as though life is a virus. It adapts, spreads, Maybe we're carrying the virus of life across the universe right now. Even in the most extreme conditions, life usually finds a way. But on a dead planet, with no geological activity to replenish the minerals and nutrients in its soil,